Welcome to Sumerix. This presentation shows how the virtual testing CFD software PumpLinx is used to model an automobile torque converter. A torque converter is a device encasing three rotors spinning in a fluid, which allows the torque from the engine to be conveyed to the transmission in a controlled manner. It has two basic functions. First, to couple and decouple the car engine to and from the wheels, and second, to increase the torque delivered from the engine to the wheels during the process of accelerating the vehicle from the stop position to the accelerating position to the cruise position when driving a car. Torque converters are commonly found in automobiles, trucks, buses, construction equipment, ships, and railway trains. So how does a torque converter work? Simply put, the engine drives the impeller, which pumps fluid through the turbine, causing it to rotate and transmit torque to the transmission. The fluid then flows through the stator back to the impeller. What are the design issues? The main design issues are the optimization of the blade shapes, since this affects the flow and hence the torque converter performance. Another design issue is to minimize power losses. Losses occur in regions between the turbine blades and the stator blades, and also in the stator itself. Another issue is to optimize the performance over the entire operational range. So how can CFD help? Using CFD analysis, the performance of many different design configurations and operational conditions can be investigated with relatively little effort compared to laboratory tests. The advantages of CFD virtual testing over hardware tests is that the performance curves can be generated without physical testing, giving comprehensive test data throughout the device. CFD allows for flow visualization, providing insight into the performance characteristics. Virtual testing reduces the number of hardware tests and in some cases eliminates the need for physical tests. CFD challenges. No method of testing is without challenges. In this case, the CFD challenges are as follows. Since the hardware is rather complex, the computational domain must be resolved using a mesh with adequate refinement of small-scale geometric features such as leakage gaps and balance holes, and must resolve regions of high flow field gradients such as boundary layers. The software must be robust enough to obtain convert solutions to problems which are inherently difficult to model. The solver must be able to perform transient simulations of full 3D geometries in a reasonable amount of time. Transient simulations are necessary to capture time-dependent physics such as pulsations and vortex shedding. The solver must be fast enough to complete a test matrix which covers the full range of operation for several design configurations. Accuracy and reliability. The software must deliver accurate and reliable results which matches experimental data so that dependability is established. Here we see the PumpLinx simulation results for a full 3D transient simulation. The torque converter impeller and turbine rotate at prescribed velocities, and the stator rotation is part of the solution and is due to the predicted fluid forces. The plots show the experimental data in blue and the simulation predictions in red of the torque ratio and K-factor versus speed ratio. PumpLinx results for a full 3D transient simulation of a torque converter matched the torque ratio experimental test results exactly for the majority of the operational range and matched to within 2.5% at the speed ratio of 0.2. If you're interested in a free PumpLinx demonstration of your device, please contact us at our website. The next few slides addresses why PumpLinx is the best tool for this application. The reasons why PumpLinx is the best tool for this particular application are revealed when we examine what PumpLinx has to offer with respect to the CFD challenges previously mentioned. Mesh generation requirements. PumpLinx uses a binary tree mesher as a general mesher, and structured meshers are available through device-specific templates. For the torque converter virtual testing, the binary tree mesher was used to automatically generate the mesh in minutes while capturing micron-scale features. It's apparent that the small-scale features are resolved quite well, and the cell count is minimized by using large cells in regions of low flow field gradients. Solver robustness. The PumpLinx solver uses state-of-the-art numerical algorithms capable of simulating physics which are known to be notoriously difficult to model, such as translating and rotating components. In addition, the setup of such models is not only extremely simple using the PumpLinx templates, but the results have invariably been consistently accurate and reliable. PumpLinx is fast. Not only is mesh generation exceedingly fast, but the solver execution time for complex multiphysics simulations shows that PumpLinx is the fastest currently available on the market. PumpLinx is 10 to 30 times faster than other codes. This means that transient solutions are obtained in a tenth of the time required for other codes. Transient simulations are indispensable for any time-dependent physical phenomena such as pulsatile pressure waves, vortex shedding, or capturing the periodic behavior of the fluid flow throughout the device in general. This slide shows a comparison of a transient simulation performed by PumpLinx and another leading CFD code. It took PumpLinx 32 hours to analyze a 1.6 million cell model, whereas the other code took 212 hours for a model half the size. Solution accuracy and reliability. The most important quality of PumpLinx simulations is that they are consistently accurate to within 2 to 5% of experimental data. The reliability and exceptional quality of PumpLinx performance is then self-evident when the track record is considered. So to summarize, PumpLinx has the latest in numerical technology. It has the best cavitation aeration model available. It has an automated and accurate mesh generator using binary tree meshing. The CFD solver is 10 to 30 times faster than our competitors. It has an intelligent GUI with templates to guide and optimize, resulting in responsive rapid development cycle. PumpLinx has an interface matching algorithm, and it comes with virtually unlimited support. Please feel free to contact us if you have any questions. If you would like a free demonstration of a PumpLinx CFD analysis modeling your device, please contact us and we will make the necessary arrangements.